Let's talk about views. Now, most of us, if not all, have used views in databases at some point, especially while dealing with relational database systems like MySQL or Oracle DB or PostgreSQL. Snowflake supports exactly the same. The concept of views in Snowflake is the same as any other SQL engine. A view, in simple terms, is basically a predefined SQL statement. It allows the result of a query to be accessed as if it were a table. View serves a variety of purposes, combining segregation, protecting the data. It makes our code more clearer, modular, and the code can be easily decomposed into smaller chunks. This is especially for large transformations. Let's say you're writing 200 lines of SQL transformation job, and this transformation job involves three large tables. And in each of the tables, you're writing some heavy transformation. Now imagine your colleague needs to debug this code. This is a typical use case of a view. That's when you might want to split each of these transformations into smaller chunks and create a view out of each one of them so that it becomes more modular and easy to handle. Views are of two types. You have non-materialized views, or simply known as views, and then you have materialized views. A materialized view is a pre-computed dataset derived from a query specification, which is persisted for data use, later use. So when you define a view as materialized, the keyword materialized, it means the data of the result is persisted on the disk. And hence, querying a materialized view is much faster than executing a query against the base table of the view. So if you compare the performance between materialized view and view, a simple view, materialized views are much faster and they're better when it comes to heavy aggregation jobs, especially when the underlying data does not change. Materialized views can speed up expensive aggregations, projections, selection operations, especially those that run frequently and run on large data sets. Snowflake supports secure views. Now, the keyword secure is something that you might not have come across in any other data warehouse. The concept of secure applies to views and user-defined functions both. When you define something as secure, let's say you define a view to be secure, it means you are making sure the underlying database or the underlying table is not exposed accidentally to the user. So views should be defined as secure when they're specifically designated for data privacy. With secure views, the view definition and the details are only visible to authorized users. Both materialized and non-materialized views can be defined as secure. Like I mentioned, a secure view has improved data privacy and data sharing. Also, both views and materialized views can be clustered for better performance. Now, this is a very important point, and clustering is one topic that we haven't visited yet. I'll be covering clustering in detail in the next section. But for now, just keep in mind that clustering does not only apply to tables, you can also cluster a view, meaning you can actually add a clustering key to a view to ensure not the entire data is scanned. Now, another important point about the keyword secure is that it does not only apply to views. When it comes to using the keyword secure, it applies to views and UDFs both. And I've explained this concept in detail in the UDF section. So that was all in theory about views. In the next video, we'll be actually writing some SQL statements and creating views and materialized views. So I'll see you guys there.